All right, part two. We're expanding our knowledge of the derivatives, and we're going to look at the derivative of not only x squared, but a constant in front of, or x to the n. We're going to put a constant in front of our expression with x. So x to the n has now a constant in front of it. And when you're taking the derivative of a constant times an expression in x, like that, thus the constant can come across the derivative sign, is not affected by the derivative, so you can call it the constant times the derivative of x to the n. And that will make more sense by example. So say I give you y equals 4x cubed. And notice we knew how to find the derivative of x cubed, but I've thrown in a 4 as promised in the general rule. So when we do that, the 4 is not going to be influenced by the derivative, so it will just sit there. Now we use the power rule. The 3 runs down in front and reduces by 1. And now we clean up our expression and we get 12x squared. So notice that is how it works when a constant comes up in front of our expression x raised to the n. What about this one? Can I find the derivative of that expression knowing these two things? Yes, indeed. So turns out we can force this to be written as 2 times x to the minus 1. Do you see, when we use the power rule, we want x raised to some number, and x in the denominator is the same as x to the minus 1. Now I can use this new expression. The 2 will not be affecting the derivative, so I'm going to use the derivative. The negative 1 runs down in front and decreases by 1. Cleaning that up a bit, I'll call that negative 2 over x squared. And that's the derivative of this function. All right. Before we close it down for tonight, there's one more general expression I want to increase your knowledge by, and that is what happens if I have the derivative of several functions added together. And doesn't matter how many I add together. The derivative of the sum of functions is going to be the same as the derivative of each function added together. So the derivative of several functions added together is the same as the sum of the derivatives. The derivative of a sum is the sum of the derivatives. All right, so I can give you an example. Y equals x to the third minus 2x plus 5. Here we have our f of x, our g of x, and our h of x. So we have 3 functions that are added together to make one function. So to find the derivative of the whole expression, you just do the derivatives step by step and add them. So the derivative of x to the third is 3x squared. There's a 1 written 1 there. The 1 runs down in front and is multiplied by the minus 2, and this reduces by 1, so we'll clean up our mess. And we already found the derivative of any constant is 0. So we end up with y prime equals 3x squared minus 2x to the 0 being 1. All right, I think I could drop you off there, and you can be well ready for tomorrow's assignment. That's where we will take expressions like you've seen tonight, find their derivatives. You will take expressions and find the equation of a tangent to that function at a given point, and you will find the slope of a function given at a given point. All right, so let us close it down for now. Till tomorrow.